Let's go over a couple things. I'd like to talk a little bit about our current project and how we're moving forward in PnR. And I'd also like to talk a little bit about how students, especially those that have missed a lot of class, can practice and get caught up a little bit with some of the Python concepts we're being discussed. And I'll start with that one because that's an easy answer. Check out codecombat.com. It's a pretty fun game. I play it a lot myself. It's a nice way to practice some Python concepts. It's fun. It doesn't take as much focus as Code Academy does. So check it out. I think that'll help strengthen your Python fundamentals while also exploring some new ideas. So very similar to the type of programming we do in Python with our GoPiGo. So now let's talk about our current project. Right now we're on a warm-up project that's right before our final. And again, your final project is to build a self-navigating car that will help you, that will autopilot its way out of a maze. So before we get there, we're getting our robot to dance. And you're building your code on top of this project that I've given you. So the whole class has made their own copy of this code. It's called forking the project, so which is how Git works, but I won't get into that. That's an extra complication that we don't need to worry about. Um, but I would like to walk you through how this framework that I've built is working, how it can help you, and also real quickly, why I'm doing this. I'm doing this because whenever I work on a project on my own around the house, working on my Raspberry Pis or whatever, I always start with an existing framework. There's no reason if I'm building a website to start totally from scratch. There are tools that make my life a lot easier and build in a lot of features that I wouldn't have time to program from scratch anyway. So this is a good example of working with a framework. Okay, so let's take a look at the code. The code really starts in the parent class. This is something that you are not going to need to edit. Okay, this is something that you shouldn't need to edit. My framework that I've been building is still, we're exploring new topics, so I'm bound to get a lot of things wrong, and so I beg your patience, and hopefully the learning process is good for both of us. Okay, so right here, I'm just going to go down the code and explain each piece. So skip through this video as you need. So right now I'm importing the GoPiGo library. It's really helpful for me to have the GoPiGo library here and not inside your child class called student.py. So the parent class does all of the GoPiGo methods. One of the advantages there is that your student.py won't have the errors because your Windows-based computer can't install the GoPiGo library properly. And so this way, if you were using PyCharm and you had this imported, it would say, hey, I can't see this library because it only exists on your Raspberry Pi and not on the computer where you're programming this stuff. And then all of the commands that you do to make like the servo, the head of the robot, turn one way or another would all be read and underlined as well, because it says I don't know how to do that because I can't load the library where that command is housed. So because all of that code is now sheltered inside this parent method, you can debug and be a little more comfortable programming in the student class. Okay, so importing this just helps me call the time.sleep command, which makes my robot's brain take a pause. Okay, uh, the init method is called when I create a new object of this. So once again, you are an instance of the human class. So if this said human and we were talking about you, we would say, you know, Billy equals a new human. And that way, during your initialization period, or, you know, for you it lasts 9 months, for this it'll last like 9 nanoseconds. It just takes a couple moments to create something in a computer. But this is the initialization, or the constructor, and it sets up a bunch of variables. It stores what degree of your servo is the middle, what makes it look straightforward. Um, this is going to indicate how close in centimeters can something get before you say, oh, my vehicle needs to stop so I don't run into that. Um, and then the default speeds for your left and right motors. We can tune these down, not in this parent method, but in your child one. We can tune these down, so if your right one pushes harder and as a result, your vehicle slowly veers to the left, we can lower that right one down a little bit so it balances out and you drive smooth and straight. And this scan, it creates, this is called a list, and it'll create 180 blocks of nothing. And because they don't store anything at the moment, they will store a number when I use my servo to go from to the right of my midpoint and then scan to the left of my midpoint. And it will use the sensor, the little two eye things that look on the top of the GoPiGo's head. It will use those sensors to take readings about how far away things are, and they'll all be stored in this list of scan. And that way, because I made 180, we won't use all of the spots, but that way the number of the spot, it will correspond with the degree that the servo was aiming at when it took the reading. So we can say at 90 degrees or whatever is directly in front of me, I saw this. And at 120 degrees, which is to my left, the way the servo is set up, I would get a reading there. Okay. Now, this right here is a little bit of advanced programming. And this right here just says only run this stuff if I said Python PIGO, so this file, if I launched this file and not student. So you shouldn't ever see this because this is only running if you launch the app from this file and not your child file. Okay, this is the menu. It creates what's called a dictionary. We've done this a little bit before. So it creates it links a key. This is the index, and then it binds it, and this inside here is called a tuple. It's its own object. It's a little complicated. It's similar to a list, but it's immutable. It can't change. A bunch of technical stuff. You don't really need to worry about this. I mean, I stole this whole stuff from code I Googled. So you don't need to necessarily, this is somewhat advanced, so it's okay if you totally aren't comfortable with it, as long as you can realize, oh, you know what, if I copy this and add a new thing, I can change what this list says, and I can make it call other methods. So that's basically all you need to know there. I'm going to skip over open house and be shy. These are just demonstration methods that my parent calls when I'm giving a demonstration during open house. These are blank methods just to set up for the child class. Okay, so these are the helpful ones that I want to show you. Now, normally when we practiced, we did a lot of these things on ourselves. We set up an encoder target for both the left and the right motors, and then we gave it an encoder target. Your wheel on the inside, underneath your robot, you can see the little black disc has 18 spokes in its wheel. So if I said 18 here, it would mean that I wanted to set the target to turn 18 spokes of my wheel and then stop. And then I tell it to go forward, and it will go forward 18 spokes and then stop. Now, the thing is that if I did this, and while it was trying to move forward, and my GoPiGo will listen to commands and do exactly what it says, if I told it to do that and then told it to do this instead, it would stop what it's doing and do this right away. The brain is moving faster than the body, than the GoPiGo. So my Raspberry Pi is executing commands faster than the GoPiGo can follow. And so we tell the Raspberry Pi to sleep. So wait a little bit. And in fact, this should be a little bit different. 1 second. Okay, that's better. So what the change that I just made was a problem that we were noticing in class. So we tell the Raspberry Pi's brain to sleep for a second, but when the encoder value is really small, it gets divided by 18, and so it makes it such a small fraction of a second that it really doesn't have time to move even a little bit. So we add 4/10 of a second onto that value. It may slow things down because your robot may pause a little bit between movements, and so we might be able to change this to maybe 0.3 or something. But that at least guarantees you at least 4/10 of a second to move that little bit. And that seems to clean up some of the problems that we were having. Okay, and so what I've done is that I have this print that tells you what's happening. It sets the target that you want. It goes forward. It stops. So all of this has been combined into one little message. So you can just call self.encode forward and in parentheses how many spokes you want it to go, and that's it. Self here, you don't actually have to pass that as a parameter. Because you do self dot encode forward, that self is being passed along to it. So this isn't something you need to put inside parentheses, just this number. Okay, so let's take a look at the student method. Notice there's no GoPiGo imports, just the Pigo, and that's where the GoPiGo library is connected. So that way you don't need to see any errors. So if you do see any errors, you should fix that before you push the code up to your robot and have a bad time. Okay, so there's a bunch of stuff here that you are able to change. So there's a comment here that describes what it is. And so you can configure all of that. This you don't really change. This just, once you set the left and right speed, this calls the method that's in the parent class that I was just showing you and inputs those left and right speed. So all of this happens when we create your GoPiGo, and down at the bottom, that's what it is. So really we have one line in our app. It just says, hey, make a new spot in memory and we'll call it G, and in there boot up a new GoPiggy and stick it inside that spot in memory. And when you tell the computer to do that, it goes, oh boy, okay, and it runs this init method, loads up your variables that you've customized, and then after that it makes sure the robot is stopped and then loads this menu. And this is the menu, just like I showed you before, something you can customize. And so if you press D in that menu, it will call the dance. And so the dance method right here is where you will stick your dance method. What I talked about in class is one of the ways that I'd like to approach writing an app. I like to call methods that don't yet exist. So when I dance, I like to shimmy and twirl. And maybe I like to do that like 3 times. So 4x in range, 3, colon, and then I'll put these types in there. So my form of a dance, a shimmy and twirl, and I do that 3 times. So now I'm calling these things that don't exist yet. But once I'm done laying out the outline of my app, I can then go through and start adding the methods that will make it work. And I can comment these parts that don't exist yet out, so I'll test it. each step of the way. I hope that this helps. Let me know if you have questions.